Hello.
Hey, how's it going?
How are you?
Good.
You got my email? You sent me an email and I replied.
Yeah, I think so.
Okay, so based on what you discussed, if you want that, just let me know, okay?
Okay.
Annie, how are you?
Hold on. I'm good. How are you?
Good, good. So let us begin then. I think I will close so much. Okay. All right, I'm going to close some of them. So we're going to conclude the concepts of probability today. Let me close this so that has enough room. Okay, good. Yep. So we are going to conclude it today. Then, actually, on Monday, we're supposed to conclude it yesterday. So, on Wednesday, so that we can do the counting rules today. But because of the break we had, we didn't have a class on Wednesday, so that's why we're concluding it today instead. Now, next week I'm gonna put the assignment for next week. So that assignment will be for the topic we'll be discussing on part of the topic we'll be discussing on Wednesday next week, because Monday is actually the random of this section of the course. Anyway, today we start with conditional probability. In life, a lot of things in life are conditional. So many things, in fact, most things are conditional. We have the condition of, for example, getting the scholarship. There's a condition for it. You have to qualify for it. Maybe good GPA, good grades. Then getting a job, something you have to have the qualification they need. Everything basically is conditional. There's a condition for of course, let's say winning a case in the court. Yeah, you have to have a good lawyer that will have all the evidences they needed. That's the first condition. Then the jury, based on what they presented to the jury, then the jury cannot decide whether you are guilty or not. So I will even the so-called love is also conditional too. They're gonna be okay. Either there are many reasons why people fall in love. One person might say, okay, he's a cute guy, or she's a beautiful lady, or he is a good guy, or there's usually there's gonna be something, and that is the condition. And we recognize that in statistics, and we call it that kind of probability, conditional probability. Anyway, so the conditional probability of an event A occurring, or maybe, or even B, I use B here, that even B will occur, is the probability that event B will occur, given that event A have already occurred. So I will give you an example. Let's say that you want to transfer your you're already in a university, so that's not the case. Well, actually can use it. Suppose you want to do a graduate program, excuse me, in another university. The condition might be that you have to finish how many credits of your you have to finish your own bachelor's degree first with a good GPA. Some colleges accept higher GPAs, some accept regular medium. But so let's say that the college is competitive, so they have their requirement. That requirement becomes the condition, but before they can now accept you to come and do your masters, stuff like that. So suppose that the condition is that you already have you already have your degree, bachelor's degree, okay? This is that it is the A, event A, then being accepted, masters equals B. Well, I think I can put it in a different way. Let's say that B is have bachelor's degree, A that you will be accepted for a master's degree. So the probability of being accepted, given that you already have a bachelor's, is the probability of A and B divided by the probability of B. So the probability of B here is the condition. See, given that this one, the B, that is the bachelor's degree, have already occurred, you already have it. So that's how I think that will give you a picture of what conditional probability is. So let us try an example here. It says, let's choose what, let's do this one. It says, I'll make it a little bit big. Okay. So now the conditional probability, the test result for marijuana use is presented on the table below. These are the test results. It says, this is the question that has been asked for this example. It says, does the subject actually use marijuana? Yes and no. Now, yes, if the test result, the blood test shows a positive result, a negative result, because we have a false negatives and false positives. Anyway, these are the results. There's a positive result, which means that marijuana is present in the blood. There's a negative result. Now, does the subject uses it? Yes and no. Now, it says choose one subject at random. Find this probability that the subject tested positive, given that he or she actually uses marijuana. This says the subject actually uses marijuana, given that he or she tested positive. Then C is the subject tested negative, given that he or she uses marijuana. So some people, when I say this part A and B, they say, oh, they mean the same thing. They actually don't, because the conditions are different. So let us solve this. Solutions. Let us let's say that the subject uses marijuana. Yeah. Okay. Then the opposite is M complement. That it doesn't use marijuana. Yeah. MC means does not use marijuana. Okay, let me make it a complement that like it should be. Okay, now, yes, see, positive results. It's, okay, you know what? I think it's better to use yes and no. So let me put it this way: yes. Let me use no. No, did not use material. Then, next one is B. Positive results. P is for positive results. Tested positive for marijuana. And then M is negative results. Okay. So once you identify them like this, it makes them easier to solve. Now, we're ready to do some work. So, A, let us put the totals together so we can be able to figure out, the row totals and the column totals. So I'm going to add the one row here and one column here so that we can get all the totals. I'm going to put it right here. Now, and then, oh, excuse me, I think I missed it up. I'm gonna put it right here. Yeah. From here. So I will affect the other one. Okay. Now I can move this a little bit. Totals. So we add this to 119 plus 24. For that, I got I added it already here. So I got 143. 3 plus 154 give us 157, I believe. And when you add this to 143 plus 157, that'll give us a total of 300. Now, next is to do the same here. Now, we have this to give us 122, and this one give us I think get 178, I believe. So now, as I check these two, when you add these two, you should get 300. So 122 plus 178. 122 plus 178 says 300. So that's tell us that we are good to go. So at this table, you have to be careful, because if you make a mistake on the table, all your answers will be wrong. Now we're ready to calculate. We're looking for this. The first one says the subject tested positive, given that he or she uses marijuana. So we're looking for tested probability of that he tested positive, P, given that he or she uses marijuana, which is yes. See, this is the probability we're looking for here. This one. Now, I want to tell you something. One thing, how we know that this equation is involve conditional probability is this keyword, given. If you give it, we have to mention, we say given. That's how you know that it is a conditional probability. If you look at all the equations, they all have that term given. So let me go to it, because this section will let me put the formula right. Let me go and put this on our formula workbook. Let me write it down first. Probability of positive result given that he uses marijuana. Okay. Now we go there. I'll take you there now so we can put the formula the right way. The probability of the subject tested positive, given that he uses marijuana, which is a yes. Okay. Oh, excuse me. I see. Okay, given that he or she uses marijuana, positive, given that he uses marijuana, which is yes, equals probability of positive and uses marijuana, okay, divided by the probability of that he said uses marijuana. So this is the formula we are going to be using, and I will take you there so I can make it bigger. So I'm gonna right here. This is the formula we're using. This is what we're looking for. So when we look at the equation, that's what it's asking for. The subject tested positive, given that he or she uses marijuana. So now we're gonna figure this out. Here, so that the probability of P, given that he uses, becomes P and Y. That's the positive and marijuana use. You look at the chart. Positive is right here, all the way to the end. and the yes is here on the column all the way to the end. So you can see that the positive yes. So they intersected. This is where they intersected. So this represents positive and use it marijuana, which is 119. Yeah, 119 divided by, oh, I forgot to put PY. My formula, let me correct my formula. I made a mistake on the formula. Divided by probability of Y. Okay. Now, so that means we have it in that form, or you can have it in this form. Probably number of points in positive and yes, which is the condition. Number of points in yes. Yeah, that's what we're using. Okay, so I'm gonna put it here. So I'm gonna replace this with this. So now that is the formula right here. So number of points in positive is 119, like I showed you here. It's 119. Then number of points in marriage in a Y, that means which means uses marijuana is all the yeses here. See the condition right here is 122. 122. So 122. So this part is number of points in yes marriage, positive and marijuana, just positive result given that they use marijuana. So you can see it at the numerator is 119. The number of points or the probability that they use marijuana is this. Okay. Now, when you divide this 119 by 122, 119, okay, 119 divided by 122, it was 0.9754. So to 3 decimal places, 0.975, 0.975, okay, 0.975, or if you like, I can call it 97.5%. So the probability that the subject tested positive, given that he or she actually uses marijuana, is 90.975 or 97.5%. Any questions on this? Hello, class?
No.
I
No.
don't have questions.
Okay, good. As B says, the subject actually uses marijuana, given that he or she tested positive. So see, this one is saying the subject tested positive, given that he or she actually uses marijuana. And this one says the subject actually uses, given that he or she tested positive. Now, you can see that the condition here is that she actually uses. But the condition here is that she tested positive. So that this is where people say that they are the same. They're not the same because of the different condition they have. You will see on the result that we calculated. So the subject actually uses. Uses means we use X, sorry, Y to represent the yes. That means that they use it. So it means the probability that the subject uses, given that he or she tested positive. See, you can see that the different conditions here. So so this is where we make an adjustment to the formula Y given P. Write it down. Probability of Y given positive. So I'm gonna adjust it and put it right here, and then we apply it right away. So taking you to the formula page, the other workbook, I mean to say that he uses marijuana, given that he tested positive. Okay, positive. It will be probability of uses and positive test. Now the condition is now positive. Okay, which is uses and positive test, uses and positive test, number of points in uses and positive test. And okay, this time condition is positive. So I'm gonna copy it and paste it in our main workbook so you can see the slight difference in outcome. Okay. So this is the formula we'll be using here. Slight change. So that means probability of using marijuana given that it tested positive equals have probability of if you go here, you see number of points in uses marijuana given that it tested positive, Y and P. You can see Y, yes, given that it tested positive, yes. So probability is yes is right here, given that it tested positive. You can see that the intersection is also 119. To have 119, which is here, it represents this part. Now, it said the condition is now that he tested positive. For the positive results, you see all the positive results is on this side. The condition is total is right here. So that's what makes it different from the other formula, where the condition is yes. This time is now the condition is positive. If it's 143, it's 143. 143. Okay. So now 119 divided by 143. 119, we got 119 divided by 143. Okay, 0.832. 16, it continues. So, but I usually like to stop on 8.83 three decimal places. 0.832. So 0.832. Or you can call it 83.2%. So the probability that the subject actually uses marijuana, given that he tested positive, is this 83.2% chance. So it's very close to the probability that the subject tested positive, given that he uses. Now, the last part of it is the subject tested negative, given that he or she uses marijuana. So that you use and then test negative. Let's see the probability here. In that case, we're looking for the probability that the subject tested negative, given that he or she uses. Probability of negative result, given that he or she uses. Okay. Now, a slight change in the formula. Let me write this down. Probability of negative results, given that he or she uses. We have here, negative results. Now, slight change in the formula because now the condition is different and the what we're looking for is a little bit different. Negative results. So you have negative results, given that he or she uses marijuana. So the chance of testing negative, even though you use the marijuana, is not because so the condition changes a little bit. Negative results and use this. Okay, negative results. Okay. Now I can copy it right here and paste it there. So you can see the formula right there. So first thing I'm gonna have this. So negative results gonna be negative result given that he or she uses probability of negative and uses divided by probability of uses. So that means number of points in negative and uses and divided by number of points that he uses. Now, so plugging it down, we have probability of negative that uses will now become, let's look at number of points in negative and uses. Marijuana, go up, see the negative result here and uses. Yes, uses. So you can see that negative and uses, they intersect here, right? So you have 3 here divided by, yes, probability of uses. I mean, the number of points in uses, which is the condition, is 122. 122 right there, 122. So 3 divided by 122 will be 3 by 122. Take it to the calculator. 3 divided by 122. 0.02459, which is 0.0245. 0.0245. 0.0245 or 2.45%. So there's a very slim chance that you don't use one smoke it, but you still there's a that you smoke it, but there's a negative, a very, very slim chance. So you get the idea of what conditional probability is. Any question before we go to the next one? Next thing we have.
No.
No questions.
Good. Now let us look at next type of type of conditional probability that we call the Bayes theorem. Bayes theorem uses a type of conditional probability, but modified. We have a state of nature. They give you first of all, they give you the probability that represents a state of nature. Then they want you to calculate the probability using the formula. Just a slight modification of the conditional probability. So the goal here is to calculate the probability of A given B from using the information from probability of B given A. So this is the highlight of the theorem. It says 2 events have prior probabilities PA1 and A2. It can be more than 2 events, it can be 3 events or 4 events. Then A1 and A2 are called the prior probabilities. That is the first one, because they are determined without any other information. Now, the Bayes formula goes this way. Suppose that these 2 events, there are only 2 events, you have A1 and A2. Suppose they are mutually exclusive. So assume that the conditional probabilities for the 2 events are known. The conditional probability for the first other event is B, given that A have already occurred, or B, given that A2 have already occurred. That's the 2 events. Now, the probability that event A1 occurs given B, and the conditional probability is the probability that even A, B have already occurred. So that B occurs given that A1 have already occurred times the probability that A1 have occurred. Then you repeat the same process for the other event, which is part B, that B given A. So you repeat it, first of all, you repeat this part as part of your denominator, you repeat what you have at the numerator here, then plus do the same for the other event. And if there are more than one event, do it for all the events. Like I showed here, probability of AI, I use I to represent how many events it can be, given that B have occurred. Is probability of B, given that AI have already occurred, times probability of AI divided by, then you repeat this process that you have here for all the events and put them in the denominator. Then you can now calculate the binomial, the probability that that event of interest have occurred. And what I will show you how it works with an example. It's really not it's not difficult. So let's use this one to represent it. An example. Have this it's a book club. Let me use this book club example to illustrate it. Now it says in a book club. 1 minute. Let me make this sense a little bit. Okay. Now, so a book club classify members as heavy, medium, or light purchasers. Yes, depending on them, number of books they buy. Overall, 20% of members. So I think I jumped. A book club classify members as heavy, medium, or light purchasers, and separate mailings are prepared for each of this group. Excuse me. Overall, 20% of members are heavy purchasers, 30% are medium, and 50% are light. So these are the known probabilities that you know about them. Now, a member is not classified into a group until 18 months after joining the club, but a test is made of the feasibility of using the first 3 months purchases to classify members. So the following percentages were obtained from the existing records of members. So you have this information. Even though they use 18 months membership before they classify you into heavy, but they say let us use 3 months based on what you have. So remember, they're already giving you the prior probabilities here: 20% for heavy, and 30% for medium, and the 50%. So you have that already. Now, these are the information. So in the first 3 months, heavy purchasers, only 5% of them, those of them that didn't buy anything at all. Among them, 5% are heavy purchasers, 15% are medium, and light purchasers are 60% are light purchasers. Now, among those that bought one book, 10% are heavy purchasers. Then the medium purchasers are 30% of them, and the light purchasers are 20%. So and so on. Now, as time goes on, of course, the heavy one will now start buying more. Now, he said, if a member purchases no books in the first 3 months, what is the probability that the member is a light purchaser? See? So in this example, how do you know that you're going to use Bayes' theorem? Because they give you the prior probabilities already here. See? Now, they now give you more probabilities information. And also it says here that the way they ask the question also will also give you a hint on that we're going to use it here. You have the prior probabilities, you have the current probabilities. Then they now ask you, what is the probability that member is a light purchaser? So in that case, let's say that you use solution. Suppose we use L for light purchasers, M for medium. Then here, I'm gonna put this. I'm gonna put this for here. Then medium and H for heavy purchasers. So in that case, we are looking for, it says here, the probability we're looking for is this. It says, what is the probability that a member is light purchase, given that, so you can say if a member purchases no books in the first 3 months, what is the probability that is a light purchaser? So probability of light, given that he didn't buy any book, that's 0 book. This is the probability we're looking for here. So I'm going to write the formula down so that we can, excuse me, solve this question right away. Now we have, I'll take you to the formula part of the book, and then we can now put it together. Then I'll copy it back here. So we're going to take you here. Probability that member is a light purchaser. Okay. Given that he didn't buy any book, so no book, equal, I put it in the formulas here. The probability is the light purchaser of didn't buy any book, given that he's a light purchaser. Let me see if this work. Oh, let me put it. Sometimes it does this. Okay. So the probability that he's there, he didn't buy any book, given that he's a light purchaser. Okay. Times, I'm going to use this that for this to represent times. Yeah, times the probability of light purchaser. Okay. Now, you repeat this. Remember, we have medium and also heavy. So you repeat this process here for all of them at diameter. So you have probability of 0. Probability of 0, 0, given they gave it already. Given light purchaser times the probability of a light purchaser. So now plus, because you have light and heavy and medium. So, and they gave you all those information. So you have to factor them in so that it will be a part of their denominator or sample space, you know. Plus probability of 0. Oh, this 0 given medium purchaser times the probability of medium purchaser. So you factor in that in because it's part of the equation, plus the probability of 0 given heavy purchaser, 0 given heavy purchasers, okay, times the probability of heavy purchasers. See? So you start with the one that we are looking for, light purchaser, given that a person bought, didn't buy any book, you know, for doing that 3 months. What is the probability that that person is a light purchaser? So whether that the person is a light purchaser, given that he didn't buy any book, I mean, equals the probability that he didn't buy any book, given that he's a light purchaser, and the probability of a light purchaser, divided by, now you start from the beginning, so you can factor in the other part of the sample space. You repeat this, because this is the first one, you repeat it here, then repeat it for the medium purchaser and the heavy purchaser. So let me copy this, and then we can put it in, our information in. And that will give us the answer right away. So we can then apply it to other form of question like this. Okay. So this is the formula right here. Okay. Now, I'm gonna write down the probabilities out here, and then we can now put them in, and then do the calculation. You see the answer. Once we get the formula right, everything will be fine. Now, probability of 0 given light purchaser is here. 0 given light purchaser is 0 given light purchaser is this. 0 given light purchaser is 0.6. 60%, which is 0.6. 60%, which is 0.6. Then this probability of light purchaser here, probability of light. We are told in the question before they give us this table that overall 20% of members are heavy, 30 are medium, and 50% are light. So probability of light to be here 50%. So you gotta be 50%, which is 0.5. Now we have that for medium. Probability of 0, as you didn't buy anything, given that it's a medium. So 0, medium, we write here. Go all the way here, you see 0. Under medium is 15%. The 15%, which is 0.15. I want to write them out before we can plug them in the formula. Okay. Now, next thing is the probability of medium. Medium will be, so like I said in the other one, before they give us this table, they told us to read that 20% of the members are heavy and 30% are medium. So medium is 30%. The probability of medium is 30%, which is 0.3. The last one, which is heavy, 0 giving heavy, probability of 0 giving heavy purchasers. Okay, it was 0 giving heavy purchasers would be, see 0 here, giving under heavy, heavy right here, 5%, see heavy, 5%, 0.05. Then probability of heavy, that's this one here, probability of heavy right here, heavy. Like the other two, before they gave us the table, they already told us that overall 20% are heavy purchasers. It's 20%, 20%, which is 0.2. Oh, I forgot to write the percent part of this one. 5%, which is 0.05. Now, with this, now we can, all we have to do now is to plug this in this formula, and then we get our answers in. So let me plug them in that in another workbook and put them here, our answers, results here. Okay, so I'm gonna put it right here, take you there, and then so probability of light given this, I'm gonna now put them in. I have them written down. It's gonna be 0 given light purchaser. We have it at 0.60 times the probability of 0. What I think times the probability of light purchaser, which is 0.05. So 0.5, which is 50%. Now I repeat it here. Okay, that's it right here. 0.6 times 0.5. Mistake. It's 0. Okay, this is just a placeholder. It's really nothing. Then plus, repeat the same thing for light and heavy. 0.15 times probability of medium 0.30 equals it. Then plus we got 0.05 for heavy times probability of heavy, which is 0.20 equals. Now I'm gonna take you to this mode so we can figure this calculator, so we can figure this out and then put the answer in. Okay, I'm taking you there. I'll have it right here. So we're looking for this probability. We have this 0.6 times 0.5. Okay. divided by 0.6 times 0.5. No, I'll make a mistake here. 0.6, 0.6 times 0.5 over 0.6. I put double parentheses. Okay, good. Good, got it. 0.6 times 0.5. Then come on, put plus under parentheses. 0.15 times 0.30. I mean, it's 0.3. Okay, close it. Then plus, our last one will be for the heavy. 0.05, 0.05 times 0.20. Okay, close parenthesis. So I got 0.84507, but like I said, I usually stop at the second, third decimal places. 0.845, 0.845, 0.845, 0.845, or you can call it 84.5%. So you have it. I'm taking it back to our main workbook so that we can round up. It's right here. It's the answer we got. So in a base theory, okay, just identify the outcomes you're looking at, then plug them in, or usually they give you the prior probability, and then you can now use other probabilities to figure out what you're looking for. So the probability that the member is a light purchaser, given that he didn't buy any book in that 3 months, is 85.4%, 84.5%. Any question for me? Any question, guys?
Oh, no questions.
So let me just take
No.
that and then send down and then we can start here like that. Timber. Aaron. Fine. You don't have any question? I will see you next on Monday.
All right, have a good day.
Have a good one. Thank you.
Enjoy your weekend.